but go through the CLR, Microsoft Intermediate Language Code, MSIL. When we compile our .NET program using any .NET language such as C#, VB.NET or C++.NET, etc., our source code does not get converted into the executable binary code, but an intermediate code known as MSIL, which is interpreted by the command language runtime. MSIL is operating system and hardware independent code upon program execution. This MSIL intermediate code is converted to binary executable code called native code. Cross-language relationships are possible as the MSIL code and similar for each .NET language. Just-in-time compilers, JITs. When our IL compiled code needs to be executed, the CLR invokes the JIT compiler, which compile the IL code to native executable code .exe or .dll that is designed for the specific machine and OS. JITs are different from traditional compilers as they compile the IL to native code just in time. So the part of the code that is not used by that particular run is never converted to native code. If IL code is converted to native code, then the next time it's needed, the CLR reuses the same already compiled copy without recompiling. So if a program runs for some time, assuming that all or most of the functions get called, then it won't have any just-in-time performance. As JITs are aware of the specific processor and OS at runtime, they can optimize the code extremely efficiently, resulting in very robust applications. Also, since a JIT compiler knows the exact current state of the executable code, they can also optimize the code by inlining small function calls like replacing body of a small function when it's called in a loop, saving the function call time. Although Microsoft stated the C# and .NET are not competing with language like C++ in efficiency and speed of execution, JITs can make your code even faster than C++ code in some cases when the program is run over an executed period of time like web servers. The Framework Class Library, FCL. The .NET Framework provides a huge framework or base class library for common usual tasks. FCL contains thousands of classes to provide access to Windows API and common functions like string manipulation, common data structures, IO streams, threads, security, network programming, Windows programming, web programming, data access, etc. It is simply the largest standard library ever shipped with any development environment or programming language. The best part of this library is they follow extremely efficient object-oriented design patterns, making their access and use very simple and predictable. You can use the classes in FCL in your program just as you would use any other class. You can even apply inheritance and polymorphism to these classes. The Common Language Specification (CLS). Earlier we used the term .NET Complaint. Languages can make use of CLR and FCL. But what makes language a .NET Complaint language? The answer is the Common Language Specification (CLS). Microsoft has released a small set of specifications that each language should meet to qualify as a .NET Complaint language. As IL is a very rich language, it is not necessary for a language to implement all the IL functionality. Rather, it merely needs to meet a small subset of CLS to qualify as a .NET Complaint language. This addresses language design issues and lays down certain standards. For instance, there shouldn't be any global function declarations, no pointers, no multiple inheritance, and things like that. The important point to make here is, if you keep your code within the CLS boundary, your code is guaranteed to be usable in any other .NET language. The Common Type System (CTS). .NET also defines a Common Type System (CTS). Like CLS, CTS is also a set of standards. CTS defines the basic data types that IL understands. Each .NET Complaint language should map its data types to these standards data types. This makes it possible for the language communicate with each other. Garbage collection (GC). CLR also contains the garbage collector, which runs in a low priority thread and checks for unreferenced dynamically allocated memory space. It finds some data that is no longer referenced by any variable. It reclaims it and returns to the OS. The presence of the standard garbage collector frees the programmer from keeping track of